So in this lesson, I'm going to try and give you an intuitive explanation of the variance inflation factor. So it's mathematical. There's a lot of steps involved in calculating it, but it has a nice geometrical explanation, and that's easier to explain through video. So in a normal linear regression, when you have two continuous predictors, or what you're actually doing is you're fitting a plane to your data. So imagine that there's a y-axis here. The first covariate is on this axis, and the second covariate is coming right for you. What you're actually doing is fitting a plane to this data. So maybe if you've got a point here, a point here, a point here, a point here in these random areas, then this plane is the one that comes closest to hitting all of the data. And so this plane has a slope in this direction and a slope in this direction. It's a little bit up in that direction. It's much more up in this direction. And there's an intercept somewhere. And so this is essentially what linear regression is doing in 3 dimensions. The problem comes when all of your points fall on essentially a single line. So imagine that there's a point here, a point here, a point here. If all of the points are directly on this line, then sure, this plane fits the line quite well. It's going through every point. The error is going to be very low. The problem is that this line, or this plane, also fits this data well. This plane does, this plane does. Any plane that intersects with this line is going to fit all of the data quite well. And so the variance inflation factor is capturing this. Essentially what the model is saying is that it doesn't know which combination of slope parameters fits the data the best. There's plenty that fit equally well. So all of those configurations it's saying are basically the same thing. It can't decide between one combination of slope parameters and another combination of slope parameters. And the way it communicates this to you, the way a model always communicates uncertainty to you, is through the variance. So when two covariates are very correlated or perfectly collinear, then the model just raises the variance to say, I can't decide how to fit this data. These points are on a line. Lots of planes will work for that. So that's the idea behind variance inflation factor. It's just the model's way of saying to you, there's lots of different slope parameters that would work for this. I can't give you a single answer.